And today we are discussing about semiconductors. What is semiconductors? Semiconductors are the materials which have conductivity between conductors like metals and insulators like ceramics. So, semiconductors can be compound such as gallium arsenide, or it can be like pure elements such as silicon or germanium. So, coming to classification of semiconductors, there are two types of the semiconductors. One type is intrinsic and extrinsic, and silicon and germanium comes under intrinsic semiconductors. And in extrinsic semiconductors, again it is divided into two types. It is p doping and n doping. Coming to n doping, N-doping means an intrinsic semiconductor like silicon and germanium doped with phosphorus and arsenic, 5A group elements, as an impurity. So the majority carriers will be electrons. Coming to mechanism, here the phosphorus will be have 5 valency electrons and silicon will be have 4 valency electrons. So it makes 4 bonds with phosphorus and 1 electron will be remained. Due to this electron, it conducts the conductivity, so it acts as a conductor. Coming to p-doping, p-doping means an intrinsic semiconductor like silicon or germanium doped with third-year group elements like boron or aluminum to increase the conductivity, and the majority carriers in p-doping are holes. Coming to mechanism, in boron there will be only 3 valency electrons and it makes 3 bonds with silicon, and there will be a hole in which there is no availability of electron. Due to this hole, it increases the conductivity and acts as a conductor. Coming to band theory of semiconductors, the energy difference between valency band and conducting band is called band gap. And band gap decides the materials as conductors, insulators, or semiconductors. Here, here the gap between conducting band and valency band is more. So it acts as the insulator. And coming to this diagram, in this conducting band and valency band, there is no gap between them. So the electrons will be shifted from valency bond to conducting band, which is responsible for conductivity. So it acts as a conductor. In this diagram, here the conducting band and valency band, the distance is not very much and not very less. So it is in the medium gap. So it is acts as semiconductor. Fermi level. Fermi level means the highest energy level that an electron occupies at the absolute zero temperature. Absolute zero temperature means there is no temperature, means 0 Kelvin. At 0 Kelvin temperature, the electron occupies highest energy level. So that level is called Fermi level. Always Fermi level lies between valency band and conducting band. Coming to properties of semiconductors, there are so many properties. Coming to resistivity of semiconductors, 10 power minus 5 to 10 to the power 6 ohm, and conductivity is 10 to the power 5 to 10 to the power minus 6 mho. Temperature coefficient is always negative, and if semiconductors are smaller in size, and then it possesses less weight, and the resistance of semiconductor decreases with increase in temperature. These are the properties of semiconductors. And coming to applications, silicon is used in electronic circuit fabrication, and gallium arsenide used in solar cells and laser diodes, and in making, and semiconductors are also used in making temperature sensors, and they are also used in making 3D printing machines, and also in microchips, self driving cars, and also to make transistors. And finally, it is used in domestic industrial applications and in making devices. Thank you.